Hello.
Hi. Hi.
Hey, good morning, everyone.
Good morning. Yeah, we'll see how many people come. The survey said 2, so.
Okay.
Okay. I'll wait 1 more minute and then I'll get started because we don't have too much time. Is this visible?
Yes.
Nice. Okay, I'll get started. So I had some feedback that, we've been like rolling out a bunch of Bazel build files and we have new CI checks, and the intended use case is that developers, gradually start moving onto using Bazel. So this is, I would like to make that happen. And if there's any questions, feel free to like jump in. And then I know also in this meeting, there's a bunch of Bazel experts that have been working on this effort. So feel free to jump in with comments there too. So for quick, I feel like I've done this slide so many times, but Bazel is a build system by Google, and it has multi-language support. So for Magma, the ones that are relevant are C, C++, Python, and Golang. I actually haven't looked at like how that would work for NMS, but I don't have inputs there because I haven't looked at it. It can also do container image construction, which I've tried, but we have not used it in like a meaningful way in Magma. And its core, principles are, it focuses on hermeticity, yeah. And by that, I mean, it focuses a lot on isolation of build environments. So it creates a sandbox for every build action you have to take, or Bazel has to take, and it sort of limits the potential question marks. And it also forces developers to configure the source identity to help Bazel keep track of the inputs and outputs of every build action. And this is useful. And this is how Bazel sort of, has reliable caching, and that enables faster builds because you can rely on caches to sort of correctly assess the the minimal, set of files to rebuild. You can also do parallel execution because also, again, Bazel has a pretty good idea of like what's dependent and what's not. And then, yeah, reliable caching, similar, but also gets you reproducibility. So this is all good stuff. Just in general, we have plans to migrate all C++ builds from CMake to Bazel. And that's tracked in this GitHub issue. I'll share the slides after the meeting. Probably should have done that before, but as of today and a few months ago, all C++ services can be built and you can run unit tests with Bazel. So if your intended use case is just to develop, that's already available to you to try out. We're also doing the same for Python. For that, we've covered most of the services, but not all. But for the ones that we've done already, you can also run unit tests and whatnot. So just the big basics, when you're sort of diving into Bazel files and sort of figuring out like what is where. I like to think of it as there are two main types of files. The first one is WORKSPACE.bazel, and in most projects, you only have one per project. And this is where you declare external dependencies and any toolchain configurations that you might have to do. So I think, like as seen in the screenshot, this is how we would pull in like glog or YAML dependencies. I think we also configure like Python, like the actual Python binary there too. So it just sort of handles everything that's external to like the actual source code. And then build files, we typically have this one per directory. It's not always the case, but usually if you have, a source code directory with a bunch of files that you would like to construct libraries or binaries out of, you would probably place a build file in that directory. The idea is that every build file sort of contains, only the build information for that directory. So should be kind of small, easy to read. So in the snippet, you can see, so I think this is from Orchestrator Gateway C common config, maybe. And this is just the build logic to compile YAML utils.cpp and HPP. So the sources are very small, so it's very modular. And you can see that you can pull in an external dependency in the depth section. And this is the same dependency that we pulled in the earlier slide in the workspace file. Oops. Yeah. And then as, in the same manner, you can also just chain together internal libraries as well. So this is an example of, so YAML utils, that's the thing that I showed you in the last slide. Service config loader is a separate library that pulls in YAML utils as a dependency. So this is kind of how Bazel builds the dependency graph. And you can kind of see how that relates to, like cache construction and whatnot. So TLDR, if you're just a developer, like trying to add and modify build files, if you're updating or adding new external dependencies, which should be kind of rare, it's not like a day-to-day thing that happens, you can look to workspace.bazel, and we actually don't put all of our external dependencies there because then it would get really long. So we kind of pull apart, language specific ones into a separate file, but it's the same concept. That you can sort of, explore in that area to see like where it might fit. For day-to-day, if you're just adding new source files, or if you're, like refactoring to pull apart existing ones, build file is usually the right file to find. For example, in like the directory that you're working in should point you to the right build file. So session D libraries are defined under session manager / build.bazel. SCTPD unit tests are all defined under SCTPD source test. So there should be a build file there. The only exception that we have is for MME, since MME has a lot of directories and a lot of cross-directory dependencies. We're not able to do this quite yet. We're working on it, but you can see that under LT Gateway C core build.bazel, there's a huge library that has most of the files. So if you're working in MME, this is probably the place to start and look. We're trying to like separate it out, but yeah, that's the place to look. And I think I'll mention in the later slide, but for anything, if you're confused about where to put things, you can just ping #Bazel, the channel, and we'll try to help you. It's usually like pretty easy to figure out if you've worked in the area for a bit. And this is just an extra bit of information because I actually was talking to Alex the other day and I didn't realize I didn't make this like super clear, but we also can generate like Protobuf and gRPC and like other types of generated code with Bazel as well. So if you look at LT Protos build.bazel, this is how we kind of declare, what kind of gRPC generations we might need. And if you look to the right, you can see that, like they're just pulled in like any other dependency. So yeah, before we dive into like a demo section, I added a slide to include all relevant command line commands, all Bazel commands that I tend to use. I would say the source of truth should be the Bazel documentation website because they actually cover it very extensively. But this is just like a snapshot of what's useful. You can see that you can run all tests in a specific directory, a single target with ASAN enabled, a single target, but like run it multiple times. We actually utilize the last command a lot to like find flaky tests, which makes it pretty easy to do. Okay, so I guess before I dive into the demo section, does anyone have any questions or? Okay, so pretty much the demo section is kind of me running some commands. And if anyone has questions, I can sort of demonstrate how I would do it or, navigate across the code. Okay. So, and in order to do the VsCode plus Bazel integration, I would follow the wiki page on that if you want to set it up locally. So here I have sorry, is that visible? Is my VsCode session visible?
Yeah.
Okay. So I have this VsCode remote session hooked up to my Magma VM. And, the terminal is pretty much, it's like the terminal inside the Magma VM. One useful thing that I like to highlight, oops. Oh, when starting out with VsCode and Bazel is you can actually have Bazel generate a compile database, which is just a single file with all the compile instructions. And with that, you can sort of enable like code navigation and, like the usual that you might expect from an IDE. So I have it documented in the slides, but you can do this. The nice thing is Bazel actually doesn't have to compile everything to generate this file. It'll just do like an extensive analysis phase. And usually if you do it from scratch, it takes like maybe 1 to 2 minutes, which is a lot shorter than building. So yes, well, I already did this already, so I don't have to wait for it, but this will enable just, your usual code navigation, jumping, it will tell you all sorts of information. And to be clear, this is doable with also CMake, but I think with CMake, you have to actually build everything first in order to generate this. So it's a little bit easier because Bazel will handle all targets, whereas CMake if you want to generate the same thing with CMake, you have to like select different CMake projects one at a time. So it's like a bit more steps necessary. But that is the navigation part. So yeah, pretty much I can run some commands like this, as mentioned in the slides. This will run everything. I actually ran the command earlier today, so hopefully we'll see that everything is cached, and it should be like fairly quick. But we'll see. That's another thing about caching. Yes, also Bazel will, if a test has been run recently and none of the input files have changed, Bazel will actually not even like rerun the test. You can of course configure it to rerun the test. You can just pass in a flag, but this way, if you're just sort of developing iteratively, it'll kind of save you time. Okay, while we wait, does anyone have any questions or anything that you would like to see demonstrated?
So these builds that we are building, that is for gateway, we have Python and C. So with Bazel, we are doing for both, right?
Sorry, I don't think I heard the first part of that question.
So the Bazel builds for our access gateways for Python and C code, both.
Yes, yeah, it's for both. So you can build both with a single tool. And like test
in our CI jobs when we are trying to build it. So how much time does it take right now? Because are we using some code which is like pre-built?
Yeah, so one thing to, okay, so you're asking about build time in CI. So first, we have jobs in CI that runs unit tests. And those on average take maybe 7 minutes or like 5 to 7 minutes to run all CC++ tests. I think to run all, actually, I'm not sure. But what we do there is we utilize GitHub Action Cache to sort of store cache across branches. And that's how we sort of get those minutes. So without cache, if we didn't have any cache and we have to start from scratch all the time, then we would be dealing with, yeah, probably like 30 to 40 minutes. Yeah, so, and that is kind of, I would say it's longer than the, the vanilla like CMake unit test runtime, because with our previous build system, we weren't building all dependencies from scratch. So if we were, if we were using Protobuf, we would just like install it and sort of link it afterwards, or, like during the build. But with Bazel, we've opted to sort of, specify like all dependencies, and like we build everything from source. And of course, if you're utilizing cache like well, you're not always building it because it's going to be like cached in your system. But that's why if building from scratch with Bazel would take a lot longer time.
So we are also like building the libraries itself also.
Yes. But yeah, so I guess some pros and cons there. It's longer, it's a lot more work to do, but it gives us like a lot more flexibility on like version management. So actually one of our coworkers on Kit, he like went on like a multi-week adventure on updating our gRPC version and on our Magma VM. But since like we sort of manage dependencies in multiple different versions, he like had a very difficult time doing this. And with these kinds of configurations, it would just be a matter of like switching a version in the hash, or I guess with this, it would be a commit. But like here, if I wanted to bump up YAML CPP, I just have to update this information.
Great.
Let's see. I'm not sure why this is taking a long time, but let's see if I can just run C++ unit tests. Oh yes, but then regarding caching, I just wanted to mention that I think there is an ongoing effort to sort of enable remote caching with S3, I think. So that, yeah, I think others can speak more to this because they've put in a bit more thought into this than I have, but that eventually would hopefully replace our GitHub action method, and like that also should be available to developers as well. So that kind of gives you like a bit more flexibility that you don't always have to keep cache locally and they can be shared. So yeah, this is an example of what I was mentioning before about, so even though I like ran the full command again, since like none of the input files have changed, like it just wouldn't even run the tests. So that's nice.
And for this local caching, of course, even without that remote cache setup, locally it's trivial to have a persistent cache that just stays on your disk all the time. So so you would have one longer run where you build everything, and from then on things are much faster.
And I guess like, yeah, another difference from our current CMake approach is that the way that we've set up our local cache is persistent across VM restarts. So they will stick around until you actually manually remove them.
Can there be a scenario if, let's say, we are building and with our new builds require new packages and build failed sometimes, or using old cache, or we just have to specify in this list like CPP repositories dot Bazel list, then it will take the latest one.
Sorry, what what was the question again?
So sometimes I've seen, let me give you an instance. If we are deploying, let's say installing some packages, and we need some dependencies. Let's say some OVS is a dependent, and with for a specific version, and with Ubuntu's different operating system like Bionic or Focal and all these things, when we, let's say, apt install OVS, we get a different version based on our operating system. So can we like face some errors or issues in compiling? Let's say we change the operating system, then what will happen to the builds?
So for the dependencies specified in these files, they're just built from source. So it's as if you're like, building them from source yourself by like running git clone or like wget. So those, if for some reason they do not build on the like OS that you're building on, that would be an error. But I think the idea is we don't want to support that many build environments. So our build environments should be very controlled. And the dependencies that are built into the executable it's just built in. So that you really probably wouldn't have to even handle too much like in runtime. But I guess I haven't really thought about like if there could be, yeah, for like runtime, for dependencies that are like we're dynamically linking, we might have to be like careful about which versions, but that is like the main reason for sort of not relying on dynamic dependencies and sort of moving towards statically including all dependencies into the executable.
Yeah, right. Because especially with the access gateway scenario, I have seen an issue with when we are building packages. It's not like packages build completely. It's more about when we try to use it. If we have built the packet in the wrong kernel version, it won't work properly.
Yeah, I think I would have to sort of think a bit more about what types of dependencies are affected by that, because yeah, I'm not sure, but I think, yeah, for these dependencies that we're building into the executable, I wouldn't expect that to be an issue, but of course, yeah, like for OVS, like for like those dependencies that is separate from the executables that we're building. So it's not like, it's kind of outside of the scope.
Yeah, good. Okay.
Okay. Well, if there are not too many questions, just continue on. So I mentioned this before, but we have some CI checks running. So I guess one thing is if any of those checks fail and it's not clear how you would reproduce them locally, please reach out to us. We'll like try to fix that or improve documentation. And if you can reproduce it but don't know how to fix the error, we can also help with that too. So that's why we created the Slack channel. So hopefully that would be helpful. We are still working on the cutover and other things like remote caching that we mentioned earlier. It's just more like, we're really excited about this build system. We would love for more people to use it. And any feedback is really welcome at this point. So thanks. And then, yeah, I just wanted to list out all of the contributors / experts in this domain. These people should all be reachable in #Bazel. So yes, hopefully that'll help. And I just added some links to, so the first document is a document that I wrote up a few months ago about like different sort of like the big why, and then also different strategies we've had to take for certain languages. So I know for like Python testing, the TNG team, they had to like make custom rules to get around some issues. So I think that should be mostly documented or linked to some other documentation. The second one is tracking all of the work. So any Bazel related issue should be reachable through that issue somehow. And then I added, I think Nils, you added this issue for just like a general Bazel documentation. I wasn't sure if there was like a newer one, so I linked it here, but feel free to edit the slides or post anything.
Yeah, right. This documentation, I mean, it's a work in progress. So if anybody gets Bazel issues, working on a pull request, please have a look, comment if something is missing there, then we will add it. But of course, as Marie said, come over to the #Bazel channel and feel free to ask any questions. We are happy to see Bazel used and will improve the migration actually if we get feedback about issues or about features that are wanted by the community.
Yes, that's it for my slides. I don't know if anyone else has questions or comments.
Mary, I have a question. Like, is there any
Yes.
scenario where you have to like delete all the cache and rebuild the code? I mean, have you faced any scenario in this?
Yeah, the only reason that I've had to do that is, unfortunately, the cache just keeps on growing. So I think I've had to do this once where I've noticed that the cache directory was very big. So I just kind of deleted it all. Ideally, you would have some like, least recently used way to like sort of reap cache, but I did not find like well, I guess I only spent like 5 minutes looking into it. So I've only had to do that once, but I've never had to remove cache due to like build inconsistency or like cache like pollution, I guess that's the word. So I found it to be very reliable.
Yeah, I would totally agree. When working on production logic or tests, I never had the problem that I had to delete all caches. Actually, I had to delete them a couple of times, but this was because of the migration, and I play a lot around with the Bazel internals. But working on general tasks, I never had to delete the caches by force.
Oh, and I guess another point is we were trying to play around with the idea of sort of, and we're kind of doing this kind of, but like maybe like, once a week or some semi-frequently, like we could sort of just post like an updated cache on S3 or whatever, something like that. So in those like rare cases that you would have to remove your cache, you could just sort of download everything and start from there, which would be much faster than, rebuilding and repopulating everything again. So that could be an option. Okay, so I guess we're done. I think this meeting is recorded, so feel free to watch it again if you want. I'll post the slides, so that's accessible. Thank you.
Thank you.
Bye.
Bye-bye.
Bye, team.
Thank you.
Thank you. Bye-bye.